Hello everybody, my name is Bhavdeep Patel and I welcome all of you in the video of 11 Science Chemistry Unit number 1, and the heading of the chapter is Some Basic Concepts of Chemistry. Today we are going to deal with another unit, mole fraction. Yes, our unit is mole fraction for the concentration. Okay. In the bracket, I have written symbol capital X. Do you remember a question? Which of the following is not going to be changed with the change in temperature? Right? Okay, think over it. Now, let us discuss mole fraction. Definition: the ratio of the moles of any component to the total moles in a solution is called mole fraction. Ratio of moles of any component. We have two components in the solution, solute and solvent, right? Whose proportion is less is called solute, and whose proportion is more is called solvent. Solute and solvent together form solution, is it? Okay, so here the symbol is capital X. The symbol of the mole fraction is capital X, and here is the formula. Point number 3. The formula of the mole fraction X is equals to moles of component, is it, over number of total moles of component in the solution, present in the solution. From the definition we can write that the moles of component over total moles in a solution. So this is the formula for mole fraction. Let us calculate one example. We are not given any example in the text, but we are going to calculate example because this is the most important example for competitive exams also. So here is the question. Calculate the mole fraction of sodium hydroxide and water in a solution formed by dissolving 4 gram of sodium hydroxide in 180 gram of water. Means we are given 4 gram sodium hydroxide and 180 gram of water. We are going to dissolve sodium hydroxide in a water. Then a solution is formed. Sodium hydroxide is less, is it? 4 gram. So I have written solute, and water is 180 gram, is a more. So act as a solvent. Together they form solution. So we have to calculate mole fraction of sodium hydroxide and water both. But here the word mole is there. Right? So what we are going to find first of all we have to find the mole, then we have to find total moles also, is it? Then we can calculate mole fraction, or we can use this formula, but we are given just gram, is it? So we have to calculate first what? Mole of sodium hydroxide and mole of water both. But in the answer, what we are going to write first? Given data. Yes, what is given? The weight of sodium hydroxide 4 gram in the bracket solute. It's for information only, is it? Now what is the molar mass of sodium hydroxide? We have used many times, right? In the case of molarity, right? So it is 40 gram. The weight of the water is given 180 gram. So is a more, is a solvent. This is only for information. Then molar mass of water is what? 18 gram. Is it? So this is all over about the given data. Now let me ask you one formula of the mole. How can you find out the mole? Using which formula? Mole is equals to the weight over molecular weight Mole is equals to weight over molar mass. You can use any word, right? So here, first of all, we are going to find out the moles of solute and then moles of the solvent. And we can write moles of any component and total moles means we have to add the moles of both. Gives us total moles. Here it is. Moles of sodium hydroxide is equals to weight of sodium hydroxide, is it? Over molar mass of sodium hydroxide. What is the formula for mole? Weight over molecular weight, is it? So weight over molar mass. So 4 is the weight and 40 is the molar mass. Division gives us 0.1 mole. This we have already calculated in the case of molarity and molality also, is it? Next, moles of water. What is the formula? Weight of water over molar mass of water. What is the weight of the water? Can you find it out from the board? Yes, it is 180. Here it is. What is the molar mass? 18. Here it is. Okay, 18 tens are 180. So answer is 10 mole. So make a box on both the answers. Now here are the moles of component both, right? Individually. Here it is component mole sodium hydroxide and here for the water. Now we need total moles. What is the formula of the total moles? Total moles is equals to the moles of sodium hydroxide plus moles of water. Okay, what is the answer of moles of sodium hydroxide? 0.1. What is the answer for the water? 10. Is it? Make an addition of both these. 10.1 moles. Right? 10.1 moles. I'm going to write down over here moles. Right? Okay. So, this is all about the total moles. Is there any doubt? If you have any doubt, please contact me. Right? Then, here is the formula of mole fraction. What is the formula of the mole fraction for NaOH? Moles of sodium hydroxide over total moles. Moles of sodium hydroxide over total moles. Okay, the mole of sodium hydroxide is 0.1 and the total moles 10.1. Am I clear? Concentrate over here. Not here. Right? The moles of sodium hydroxide 0.1, total moles 10.1. Okay, we have substituted the data 0.1 over 10.1 gives me this answer. This is the mole fraction of sodium hydroxide. Let us calculate the mole fraction of water. Mole fraction of water is equals to, what is the formula? Moles of water over total moles. Okay, here moles of water is 10 and total moles 10.1. What do you think? 10 over 10.1. Is it? So 10 over 10.1. Am I clear? Make a division in the calculator. You got this answer 0.99. Is it? Okay. So after calculating mole of sodium hydroxide in water, we have made a total moles. Right? So again, we are going to do same thing, that here we have mole fraction of sodium hydroxide and mole fraction of water is there. Addition of both these. Sum of mole fraction is equals to mole fraction of sodium hydroxide plus mole fraction of water. We have answer of sodium hydroxide here and answer of water is there. Make addition of both these. Maybe you got answer 0.999999 like that. Convert it into the next round digit, that is 1. Right? Okay. Now keep this thing in your mind. In examination, when you get the total sum of the mole fraction is equals to the 1, which means your answer is exactly right. For any such kind of example, your total mole fraction always comes 1. Is it? Means the mole fraction of both the component always become unity. So in examination, you will become confident about your calculation. Is it? Okay. Let me give some example for the practice. Here is a practice work. The first name, potassium carbonate, sodium carbonate, sodium bicarbonate, potassium bicarbonate. Okay, these are the formula and here are their formula masses. Is it clear? Where you are going to use this one? Yes, frame a question for this one. I am going to make a question first of all for potassium carbonate. Calculate the mole fraction of K2CO3. Am I clear? Potassium carbonate and water in a solution formed by dissolving 4 gram of potassium carbonate in 180 gram of water. Is it? Next, weight of potassium carbonate, molar mass of potassium carbonate. What is the molar mass of potassium carbonate? 138. So write over here 138. Am I clear with the example? Okay. Then moles of potassium carbonate, weight of potassium carbonate, molar mass of potassium carbonate 4 over 138. Is it? So your answer is going to be changed over here. Then you have to put this answer here and make the total moles. Am I clear? Okay. Then mole fraction of potassium carbonate, moles of potassium carbonate will give you some answer over here. Right? Why? Here it is. This factor is going to be changed and make a sum. Your final answer must come 1 if you have done everything okay. If it is not so, you have made a mistake somewhere. 0.99 or 0.98 something is there, then it is okay. Right? But if you did not get your answer 1, then you have made a mistake during the calculation of example. Then use sodium carbonate, sodium bicarbonate, potassium bicarbonate and do the full practice of mole fraction. So now it's time to calculate mass percent. How can we calculate mass percent? This is a easy example. So let us deal with first of all formula. Mass percent is equals to mass of solute over mass of solution. What is solute? Whose amount is less. What is solvent? Whose amount is more. What is solution? Solute and solvent together form solution. Multiplying by 100 is the mass percentage. So I am going to put over here the symbol of percentage. Okay. A solution is prepared by adding 2 gram of a substance A in 18 gram of water. Calculate the mass percentage of the solute. Means we have to calculate the mass percentage of solute A. Right? Okay. First of all, what we are going to write over here? We are going to write the given data. What is given data? Mass of solute, that is 2 gram. Mass of solvent, that is 18 gram. Is it? And total mass of the solution is equals to 2 plus 18, 20 gram. Is it clear? Is it? Okay. Now mass percent of A is equals to, what is the formula? Mass of solute, mass of A, because we have to find it out for A, over mass of solution, here it is, into 100%. Right? Then mass of A, what is mass of solute? 2 gram. That is the mass of solute means A. Here it is 2. Mass of solution. Mass of solution 2 plus 18, 20. So we are going to put 20 multiplying by 100. 2 into 100, 200 over 20. Both 0 are going to be cancelled out. We can multiply here by 10. 2 tens are 20. So our answer is 10%. By this way, you can obtain the mass percent. One example I am going to give you for the practice, that instead of 2, you just put 6. Is it? And instead of 18, you just write over here 25. And calculate your next example. Thank you very much.